So in this video, I've got 3 exercises for you, all of which involve logarithms in an integral. And I'd like you to have a go at them, and then if you come back having had a good try at them, I will go through detailed solutions. And at the end of the video, I'm going to give you some additional exercises. So see you in a few minutes. Okay, welcome back. Let's look at the answer to the first integral. So this integral may or may not look a little intimidating because of the argument of the logarithm, but remember the rules for logarithms. So whenever you have logarithms that look in any way a little bit complicated, one of the things you should ask yourself is, can I use the rules for logarithms? And you know that 1 over x is x to the power of minus 1. So what we have here is we have the integral of the logarithm of x to the minus 1. So that means that we have minus the integral of the logarithm of x with respect to x, where we used the rules for logs that the logarithm of x to the power of n is n log of x. So our integral can be written down immediately if you know the formula or the result for the integral of log of x, and I would suggest that this is a good thing to know off by heart. I will discuss how it's obtained in a moment, but if you know it off by heart, well, there is a minus sign outside, which we have here, and this integral is, open brackets, it is x log of x minus x, close brackets, plus an integration constant. So if we just tidy that up a little bit, the term that's positive is the x minus minus, so I'll write that in front. I think that's less confusing. And then we have a negative term minus x log x plus, as said, an integration constant. So that is our result for this integral, and you can verify it straightforwardly by differentiating it. Let me just remind us how this result for the integral of the log of x is obtained. What we do is to write the integral as 1 times log of x integrated with respect to x, and we use integration by parts. So I'm going to call the logarithm, I'm going to call that u because I'm going to differentiate it. If I knew how to integrate it immediately, I wouldn't need to do this revision. And I'm going to call the 1 here v prime, so I will be integrating it. So this is v prime, this is u that we're going to differentiate, and this is v prime. So u is log of x. The derivative of u is 1 over x. V prime is 1, and the integral of that is x. And we can also just recall the integration by parts formula, that the integral of u v prime with respect to whatever our variable is u times v minus the integral of, and now it's the derivative of u times v. So we've swapped around where the derivative is. And this formula is obtained from the product rule of differentiation. So that's our formula. These are the ingredients. Let's just write down what the answer is. So the integral of the logarithm of x with respect to x is going to be, so it's u times v, so it's log of x times x. To make that less confusing, I put the x in the front, so I write it as x log x. We then subtract because of this minus sign, the integral of, and it's u prime, which is 1 over x, times v, which is x, integrated with respect to x. And that's excellent because the x's cancel, so we've only got to integrate 1. So our result is x log of x minus, and the integral of 1 is x, and there is no integral left, so we'd better show that there is an ambiguity of an unknown integration constant. And that is our result for the integral of the logarithm, and it's the result that we used up here. And I think that's a good formula to know off by heart. And the key message of this example is that if you're integrating this, use the rules for logarithms to simplify the logarithm. So wherever that's possible, do it. And after that, we can just obtain the result. It is possible to write this integral in this way, but with a 1 over x here and use integration by parts. You're going to have to use the chain rule for the derivative, and it's much more tedious. With that, I'll move on to the next integral. So a lot of integration is about pattern spotting, and this exercise exemplifies that. What we have here is the derivative of the logarithm multiplied by the logarithm. And that's something that we can just write the answer down for. So what we're going to get is, I'll leave a space here just to see what we need to do to tidy it up in a moment. But basically, if you have the derivative of a function times the function to some power, and this logarithm is to the power 1, what you're going to do is you're going to add 1 to that power. So what we're going to have is something like the logarithm squared of x. Will be an integration constant. And let's just see now what we have to do here to make this an identity. So if we differentiate this, we should obtain the integrand. Let's differentiate it. This is log of x all squared. So let's just do it very slowly here down below. So the derivative of the logarithm of x all squared is going to be, so we would pull the 2 in front, so we'd have a 2 here. We would reduce the power by 1, so we would go from squared to the power of 1. I'm not going to bother writing to the power of 1, I'm just going to write log of x. And then from the chain rule, we multiply by the derivative of what's in the brackets, the quantity that is being squared, and this is log of x, so the derivative of log of x is just 1 over x, so we're going to get 2 over x times log of x. And that's what we get if we differentiate this, and that is twice the answer we want, and that's very easy to fix. We just put a factor of a half in front. And that is the answer for this integral. So again, pause, let's just look at it, check it works. So if we differentiate this, we will bring a 2 in front that will cancel with the half. We will reduce the power by 1, giving us log of x, good. And then we will multiply by the derivative of the log, because that was what was being squared. And the derivative of log of x is 1 over x, so we will get that. In other words, we get exactly the integrand, and that means that this is correct. And we are happy. Okay, so when you're getting more confidence with integration, you may need to write this down to get the answer. With practice, you will just write it down, leave a space, think for a moment or so about what the number is that needs to be there, write it down, check it in your head, and be confident that it's correct. But that's all a matter of practice. Okay, let's look at the third exercise on the next slide. So this exercise here is a slightly cheeky one. What we have is we have the logarithm squared, and the argument of the logarithm is the square root of x. And the thing that I want you to realize is that you really cannot in any way cancel this squaring and square root here. They mean quite different things. So let me just talk about what that means. Let me just write it out a bit more explicitly. So forgetting the integral for the moment, the log squared of the square root of x means the logarithm of the square root of x all squared. So whatever that logarithm is, you get the answer and then you square it. Now, we know how the rules for logs work. We practiced that in the first exercise. So the logarithm of the square root of x is the logarithm of x to the power of a half. And then from the rules for logs, you can bring the half out front. So what you get is, open brackets, 1/2 the logarithm of x all squared, since the square root of x is x to the power of a half. So our answer for this, we can just tidy it up a little bit more. We have a product squared, so we square each of the factors in the product. A half squared is going to be a quarter, and then we have the logarithm squared of x. So this means that our original integral, the integral of log squared of the square root of x with respect to x is, and it's going to be multiplied by a quarter, so I'll take that through the integral sign. So it's a quarter times the integral of log squared of x with respect to x. And you see that in no way does this squaring and square root cancel. The square root and the squaring combine to give us a factor of a quarter out front and log squared of x. So now we have to calculate this integral, and integration by parts is, generally speaking, the most overused method of integration, but for logarithms it's a very common method, and we're going to use integration by parts again now. So as in the previous exercise, what we're going to do is write the integrand here as 1 times log squared of x. So let's just write the integral of log squared of x times 1 with respect to x. We are going clearly to differentiate log squared of x, because if we could integrate it, why would we waste time using integration by parts? So this is going to be what we're going to call u, which we will differentiate, and the 1 is v prime, which we will integrate. And if u is log squared x, the derivative is 2, bringing that down, times log of x to the 1, times the derivative of log x, and that's 1 over x. So to obtain this, we used the chain rule to differentiate that. Again, look at the previous exercise. V prime is 1, so therefore v, its integral, is just x. And we also recall the formula that the integral of u v prime with respect to x is uv minus the integral of u prime v with respect to x. So this tells us that the integral of log squared of the square root of x integrated with respect to x is, well, there's a quarter multiplying everything, so I'll write a quarter and open a big brackets. And now we have the integral of log squared, and we have all the ingredients we need. So it's going to be u times v, so that's log squared of x times x. So I'll put the x in front, so it's x log squared x minus, and then we have the integral of u prime. I forgot to put the prime there earlier. Apologies. So that's u prime. And that's 2 log of x times 1 over x. I'll pull the 2 through the integration sign here. So we have log of x times 1 over x. And then that's u prime is multiplied by v, and v is x. So we have an x here integrated with respect to x. Close the big brackets. And again, when we look at this, we can tidy it immediately because the 1 over x and the x will cancel, leaving us with a factor of 1. So that and that cancel. So our integrand here is log of x times 1. It's just log of x. And we know what the integral of log of x is. We derived it, if you remember, in the first of these exercises. So it's going to be x log x minus x, and that's all multiplied by a minus 2. So let's be careful with brackets. So our answer for this integral is 1/4, open brackets, x log squared x minus 2, open brackets, x log x minus x, close brackets, close the brackets that we opened here, and add an integration constant. So that's our answer, but we really ought to tidy it. So I think what I'm going to do, there's always some choice in these matters, I'll leave the quarter outside, so keep these brackets. I'll just multiply this bracket out. So it's minus 2 times this, and then minus 2 times minus x is plus 2x. So our result for the integral of log squared of the square root of x with respect to x is 1/4 x log squared x minus 2x log of x plus 2x, close the brackets, plus an integration constant. And you can verify that this is correct by differentiating it and seeing that everything cancels apart from 1/4 of log squared of x, which, as we know, is the log squared of the square root of x. So that is our answer for this integral. So the aim of this exercise was just to make you think about the difference between the power here and the power in the argument of the logarithm. And then, having done that, all we had to do was use integration by parts, and you either view it as integrating by parts twice, or we've done it once and then we just remembered this and wrote the answer down. With that, I'm going to show you some exercises on the next slide. So here are 3 more exercises for you to tackle, just to reinforce this material. And if you could just calculate the integrals, bear in mind this integral is a definite integral. And then at the end, if you could also comment on the sign of the definite integral. So again, have a go. And then what I will do is, in a moment, I will write the answers down for you. But stop the video, have a go, and then come back. Okay, welcome back. I'm about to write the answers down. So the first just followed from using the rules for logarithms and bringing this 2 in front of the log. What about the second? Well, this is the derivative of a log times the log to a power. That means, again, we can just write the answer down by inspection. And this is what we obtain. So we've increased the power here by 1, and then we multiply by the reciprocal of the power. So when you differentiate this, that, and this that you bring in front would cancel. And that will give you this from the chain rule. What about the third integral? You're going to have to use integration by parts, and eventually what you will obtain is, and of course the logarithm of x from 1 over e to 1 is negative, or it vanishes at the very end of the integration range, but we are squaring this logarithm, so the integrand is positive. So we have a negative quantity squared. So we expect a positive result. We look at the answer here, and we have 2 minus 5 over e, and e is roughly 2.71828, etc. In other words, it is bigger than 2.5. So 5 divided by e is less than 2. Here we have 5, that's 2 times 2.5, and on the bottom we have 2.7 something. So this is less than 2. So that tells us that our result is positive, as e is approximately 2.718, etc. And we expect a positive result, and therefore that gives us some confidence in our answer. And with that, I will stop this video, and I hope it's helped you.